Hello, my dear students. Today we will start our session with an introduction to Python. As you all know that Python is the most widely used programming language today, and when it comes to solve data science tasks and challenges, Python is the number one choice. Many companies now use Python programming for their major work. Python is one of the most popular and widely used programming language in recent days. It is a high-level, general-purpose and powerful programming language. It is designed by Guido van Rossum and it was released in 1991. Python programming language is mainly used for web applications, business applications, scientific and numeric, internet development, desktop GUIs, and software development, etc. And it is the excellent choice to learn as first programming language for new programmers or beginners, as Python has huge number of libraries that make it easier for complete and complicated tasks. So let's now look at the brief history of pandas.
I was into somewhat subversive TV shows, and so Monty Python was one of those that I enjoyed watching. If you name it Python, it could arguably be named after a snake. I named it after Monty Python, but I took it from Monty Python, and it was like easy to type, not too many letters, not too many consonants next to each other, easy to pronounce. My original idea was for Python to be sort of in between shell scripts and C programming. I had this vision of people, sort of kids learning Python in school, which at the time looked pretty far-fetched because there weren't even that many computers in most schools. You can show someone, here are the basics of Python, and if they know a bit of programming in another language, they'll see, oh wow, this is very simple, this is very easy, I can understand this already. If you teach them Python instead of Pascal, they can focus more on that learning experience and less on where the semicolons do or don't go. The sort of areas where Python is used most is, on the one hand, sort of web application development, tooling, like the internal tooling we use at Google. There's a lot of that in Dropbox too, and sort of, again, Facebook. Instagram, the Instagram service is written in Python. There are many other ways that Python is used where it's either an alternative to Java or Go, or it's a tool all by itself. Scientists use it to drive incredibly powerful libraries. That world has grown bigger and bigger, and now we have like a lot of data science happening in Python. The fact that Python is easily extensible with code written in other languages. So Python is a great glue language. I cannot emphasize enough that the community did it. It is such a great place. There are so many people contributing, and yes, we also argue. I learned so much from just listening to other people explain why a certain thing cannot work or why we should do a certain other thing, and I enjoy the debate. And I'm very happy that the community takes care of all these things that I couldn't possibly do all by myself. I think my role is mostly that of a mentor.
So after this short history of Python, Let's turn to our main topic, that is Python libraries. As you all know that Python has huge number of libraries in it. So let's first talk about what are Python libraries. A library is a collection of files called modules that contains functions for use by other programs. Python library is a collection of functions and methods that allow you to perform many actions without writing your code. For example, the Python imaging library PIL is one of the core libraries for image manipulation in Python. Certain libraries that are there in your course are Python standard library, which includes math module, random module, statics module. These standard library you will be learning in the upcoming sessions. Then Numpy is one among those library, pandas another library, and matplotlib. All these libraries are there in your course, and you are going to study in detail about these libraries in the upcoming sessions. And in this session, you will learn about its overview. As I have talked earlier, that each Python, each library in Python contains a huge number of useful modules that you can import in your everyday programming. So a huge number of libraries are there. Few libraries are Numpy, which provides math functions, SciPy, which provides algorithm and mathematical tool, matplotlib, a numerical plotting library, Pygame is 2D game development library, Pyglet is a three-dimensional animation and game creation engine. PyQt is for GUI development. PyWin32 is for interacting with Windows. PyGTK is Python GUI library. Nose is a testing framework for Python. IPython is shell for Python, and SymPy being algebraic evaluation, complex number differentiation, all these are dealt with SymPy. Scrappy, a packet sniffer and analyzer. Certain data libraries used in data science are, as you can see on the screen, just these are for your information and you don't have to study about them. These are just for your information that these are the 15 Python libraries for data science. And you must know that Python uses its rich libraries for easy and efficient use and for data analysis and data solutions. TensorFlow, Keras, PyTorch, NLTK, SpySci, Matplotlib. This you're going to study Matplotlib for data visuals. Seaborn. We will talk just about few libraries, that is top Python data science libraries, which are NumPy, Matplotlib, and pandas. I just gave you the overview of how many libraries are there in Python, but we will confine our discussion in this session with NumPy, Matplotlib, and pandas. So let's talk about only the top Python data science libraries. Let's have a quick look on those.
Python is the most widely used programming language today. When it comes to solving data science tasks and challenges, Python never ceases to surprise its audience. Most data scientists out there are already leveraging the power of Python every day. Hi, I'm Apeksha from Simplilearn, and well, after some thought and a bit more research, I was finally able to narrow down my choice of top Python libraries for data science. What are they? Let's find out. So let's talk about this amazing library, TensorFlow, which is also one of my favorites. So TensorFlow is a library for high performance numerical computations with around 35,000 GitHub commits and a vibrant community of around 1,500 contributors. And it's used across various scientific domains. It's basically a framework where we can define and run computations which involves tensors. And tensors, we can say, are partially defined computational objects again, where they will eventually produce a value. That was about TensorFlow. Let's talk about the features of TensorFlow. So TensorFlow is majorly used in deep learning models and neural networks, where we have other libraries like Torch and Theano also. But TensorFlow has hands down better computational graphical visualizations when compared to them. Also, TensorFlow reduces the error largely by 50 to 60% in neural machine translations. It's highly parallel in a way where it can train multiple neural networks and multiple GPUs for highly efficient and scalable models. This parallel computing feature of TensorFlow is also called pipelining. Also, TensorFlow has the advantage of seamless performance. As it's backed by Google, it has quicker updates, frequent new releases with the latest of features. Now, let's look at some applications. TensorFlow is extensively used in speech and image recognition, text-based applications, time series analysis and forecasting, and various other applications involving video detection. So, favorite thing about TensorFlow that it's already popular among the machine learning community, and most are open to trying it, and some of us are already using it. Now, let's look at an example of a TensorFlow model. In this example, we will not dive deep into the explanation of the model as it is beyond the scope of this video. So here we're using Amnes dataset, which consists of images of handwritten digits. Handwritten digits can be easily recognized by building a simple TensorFlow model. Let's see how. When we visualize our data using matplotlib library, the inputs will look something like this. Then we create our TensorFlow model. To create a basic TensorFlow model, we need to initialize the variables and start a session. Then after training the model, we can validate the data and then predict the accuracy. This model has predicted 92% accuracy. Let's see, which is pretty well for this model. So that's all for TensorFlow. If you need to understand this tutorial in detail, then you can go ahead and watch our deep learning tutorial from Simplilearn as shown in the right corner. Interesting, right? Let's move on to the next library. Now let's talk about a common yet a very powerful Python library called Numpy. Numpy is a fundamental package for numerical computation in Python. It stands for Numerical Python as the name suggests. It has around 18,000 commits on GitHub with an active community of 700 contributors. It's a general purpose array processing package in a way that it provides high performance multi-dimensional objects called arrays and tools for working with them. Also, Numpy addresses the slowness problem partly by providing these multi-dimensional arrays that we talked about, and then functions and operators that operate efficiently on these arrays. Interesting, right? Now let's talk about the features of Numpy. It's very easy to work with large arrays and matrices using Numpy. Numpy fully supports object-oriented approach. For example, coming back to NdArray once again, it's a class possessing numerous methods and attributes. NdArray provides for larger and repeated computations. Numpy offers vectorization. It's more faster and compact than traditional methods. I always wanted to get rid of loops, and vectorization of Numpy clearly helps me with that. Now let's talk about the applications of Numpy. Numpy, along with pandas, is extensively used in data analysis, which forms the basis of data science. It helps in creating the powerful n-dimensional array. Whenever we talk about Numpy, the mention of the array, we cannot do it without the mention of the powerful n-dimensional array. Also, Numpy is extensively used in machine learning when we are creating machine learning models, as in where it forms the base of other libraries like SciPy, scikit-learn, etc. When you start creating the machine learning models in data science, you will realize that all the models will have their base as Numpy or pandas. Also, when Numpy is used with SciPy and matplotlib, it can be used as a replacement of MATLAB. Now let's look at a simple example of an array in Numpy. As you can see here, there are multiple array manipulation routines. Like there are basic examples where we can copy the values from one array to another. We can give a new shape to an array from maybe one-dimensional to we can make it as a two-dimensional array. We can return a copy of the array collapsed into one dimension. Now let's look at an example where this is a Jupyter notebook and we will just create a basic array, and For detailed explanation, you can watch our other videos which targets on these explanations of each libraries. So first of all, whenever we are using any library in Python, we have to import it. So now this np is the alias which we will be using. Let's create a simple array. Let's look what is the type of this array. So this is an ND array type of array. Also, let's look what's the shape of this array. So this is a shape of the array. Now here we saw that we can expand the shape of the array. So this is where you can change the shape of the array using all those functions. Now let's create an array using arrange functions. So if I give arrange 12, it will give me a 1D array of 12 numbers like this. Now we can reshape this array to 3, 4, or we can write it here itself. So this is how arrange function and the reshape function works for Numpy. Now let's discuss the next library, which is SciPy. So this is another free and open source Python library extensively used in data science for high-level computations. So this library, as the name suggests, stands for Scientific Python, and it has around 19,000 commits on GitHub with an active community of 600 contributors. It is extensively used for scientific and technical computations. Also, as it extends Numpy, it provides many user-friendly and efficient routines for scientific calculations. Now, let's discuss about some features of SciPy. So SciPy has this collection of algorithms and functions which is built on the Numpy extension of Python. Secondly, it has various high-level commands for data manipulation and visualization. Also, the ND image function of SciPy is very useful in multi-dimensional image processing, and it includes built-in functions for solving differential equations, linear algebra, and many more. So that was about the features of SciPy. Now let's discuss its applications. So SciPy is used in multi-dimensional image operations. It has functions to read images from disk into NumPy arrays, to write arrays to disk as images, resize images, etc., solving differential equations, Fourier transforms, then optimization algorithms, linear algebra, etc. Let's look at a simple example to learn what kind of functions are there in SciPy. Here I'm importing the constants package of SciPy library. So in this package, it has all the constants. So here I'm just mentioning C or H or NA, and this library already knows what it has to fetch, like speed of light, Planck's constant, etc. So this can be used in further calculations. Data analysis is an integral part of data science. Data scientists spend most of the day in data munging and then cleaning the data also. Hence, mention of pandas is a must in data science lifecycle. Yes, pandas is the most popular and widely used Python library for data science, along with Numpy and matplotlib. The name itself stands for Python Data Analysis, with around 17,000 commits on GitHub and an active community of 1,200 contributors. It is heavily used for data analysis and cleaning as it provides fast, flexible data structures like data frames, series, which are designed to work with structured data very easily and intuitively. Now let's talk about some features of pandas. So pandas offers this eloquent syntax and rich functionalities. Like there are various methods in pandas like drop NA, fill NA, which gives you the freedom to deal with missing data. Also, pandas provides a powerful apply function, which lets you create your own function and run it across a series of data. Now forget about writing those for loops while using pandas. Also, this library's high-level abstraction over low-level NumPy, which is written in pure C. Then it also contains these high-level data structures and manipulation tools, which makes it very easy to work with pandas, like their data structures and series. Now let's discuss the applications of pandas. So pandas is extensively used in general data wrangling and data cleaning. Then pandas also finds its usage in ETL jobs for data transformation and data storage, as it has excellent support for loading CSV files into its data frame format. Then pandas is used in a variety of academic and commercial domains, including statistics, finance, neuroscience, economics, web analytics, etc. Then pandas is also very useful in time series specific functionality like date range generation, moving window linear regression, date shifting, etc. Now let's look at a very simple example of how to create a data frame. So data frame is a very useful data structure in pandas and it has very powerful functionalities. So here I'm only enlisting important libraries in data science. You can explore more of our videos to learn about these libraries in detail. So let's just go ahead and create a data frame. I'm using Jupyter Notebook again, and in this, before using pandas, here I'm importing the pandas library. Let me go and run this. So in data frame, we can import a file, a CSV file, Excel file. So there are many functions doing these things, and we can also create our own data and put it into data frame. So here I am taking random data and putting in a data frame. Also I'm creating an index and then also giving the column names. So PD is the alias we've given for pandas, random data of 6 by 4, index which is taking a range of 6 numbers, and column name I'm giving as ABCD. Now let's go ahead and look at it. So here it has created a data frame with my column names at ABCD, my list as 6 numbers 0 to 5, and a random data of 6 by 4. So data frame is just another table with rows and columns where you can do various functions over it. Also, I can go ahead and describe this data frame to see. So it's giving me all these functionalities where count and mean and standard deviation, etc. Okay, so that was about pandas. Now let's talk about next library and the last one. So matplotlib for me is the most fun library out of all of them. Why? Because it has such powerful yet beautiful visualizations. We'll see in the coming slides. Plot and matplotlib suggests that it's a plotting library for Python. It has around 26,000 commits on GitHub and a very vibrant community of 700 contributors. And because of such graphs and plots that it produces, it's majorly used for data visualization. And also because it provides an object-oriented API which can be used to embed those plots into our applications. Let's talk about the features of matplotlib. The pyplot module of matplotlib provides MATLAB-like interface. So matplotlib is designed to be as usable as MATLAB with an advantage of being free and open source. Also, it supports dozens of backends and output types, which means you can use it regardless of which operating system you're using or which output format you wish. Pandas itself can be used as wrappers around matplotlib's API so as to drive matplotlib via cleaner and more modern APIs. Also, when you start using this library, you will realize that it has a very little memory consumption and a very good runtime behavior. Now let's talk about the applications of matplotlib. It's important to discover the unknown relationship between the variables in your dataset. So this library helps to visualize the correlation analysis of variables. Also in machine learning, we can visualize 95% confidence interval of the model just to communicate how well our model fits the data. Then matplotlib finds its application in outlier detection using scatter plot, etc. and to visualize the distribution of data to gain instant insights. Now let's make a very simple plot to get a basic idea. I've already imported the libraries here. So this function matplotlib inline will help you show the plots in the Jupyter Notebook. This is also called a magic function. I won't be able to display my plots in the Jupyter Notebook if I don't use this function. I'm using this function in Numpy to fix random state for reproducibility. Now I'll take my n as 30 and will assign random values to my variables. So this function is generating 30 random numbers. Here I'm trying to create a scatter plot. So I want to decide the area. Let's put this. So it's just multiplying 30 with random numbers to the power 2 so that we get the area of the plot, which we will see in just a minute. So using the scatter function and the alias of matplotlib as plt, I've created this. If I don't use this, then I have very small circles as my scatter plot. It's colorful, it's nice. So that's one very easy plot. I suggest that you explore more of matplotlib and I'm sure you will enjoy it. Let's create a histogram. So I'm using the style as ggplot and assigning some values to these variables, any random values. Now we are assigning bars and colors and alignment to the plot. And here we get the graph. So we can create different type of visualizations and plots and then work upon them using matplotlib, and it's just that simple. So that was about the leading Python libraries in the field of data science. But Along with these libraries, data scientists are also leveraging the power of some other useful libraries. For example, like TensorFlow, Keras is another popular library which is extensively used for deep learning and neural network modules. Keras wraps both TensorFlow and Theano backends, so it is a good option if you don't want to dive into details of TensorFlow. Then scikit-learn is a machine learning library. It provides almost all the machine learning algorithms that you need, and it is designed to interpolate with NumPy and SciPy. Then we have Seaborn, which is another library for data visualization. We can say that Seaborn is an enhancement of matplotlib as it introduces additional plot types.
So hope you have enjoyed the video. I find this video very interesting and useful. That's why I incorporated it in my session. All right, let's get back to our discussion. So we will learn. So what we have learned in through this video and know more about pandas is a Python analysis library that provides data structure and function for data manipulation and analysis. It provides fast, flexible, and expressive data structure designed to make working with label diagram in an easy and intuitive manner. It is capable of handling huge amount of data, and at the same time it provides multiple ways to handle missing data, thereby making data analysis more accurate and reliable. Pandas name itself stands for Panel Data System, which means multidimensional structured data set. Panda was developed by Wes McKinney and its first release version was 0.23.2 in July 2018. Let's discuss something about historical development of Panda. In 2008, Panda development began at AQR Capital Management. By the end of 2009, it had been open source and is actively supported today by a community of like-minded individuals around the whole world who contribute their valuable time and energy to help and make open source Panda possible. Since 2015, Panda is a non-focus sponsored project. This will help ensure the success of development of Pandas as a world-class open source project. Let's look at the timeline of Pandas. In 2008, development of Pandas started. In 2009, Pandas became open source. 2012, first edition of Python for data analysis is published. In 2015, Panda became a NumFocus sponsored project. In 2018, first in-person co-development co-development developer sprint. Let's look at the highlights of this library. Number 1, a fast and efficient data frame object for data manipulation with integrated indexing. Number 2, tools for reading and writing data between in-memory data structure and different formats is available in Pandas library, that is CSV and text files, Microsoft Excel, SQL databases, and other sources through which data can be read or write. Pandas incorporate intelligent data alignment and integrated handling of missing data. Gain It gains automatic label-based alignment in computations and easily manipulates messy data in an orderly form. It is very flexible and provides reshaping and pivoting of data sets. 5. Intelligent label-based slicing, fancy indexing, and subsetting of large dataset is available in Pandas. 6. Columns can be inserted and deleted from data structures for size mutability. 7. Aggregating or transforming data with a powerful group by engine allows split, apply, combine operations on datasets. Further, pandas has a high performance merging and joining of datasets. 9. Hierarchical access indexing provides an intuitive way of working with high dimensional data in a low dimensional data structure. 10. Time series functionality, highly recommended in pandas, is a data range generation and frequency conversion, moving window statistic, data shifting and lagging, even create domain specific time offsets and join time series without losing data. 11. Highly optimized for performance with critical code paths written in Python or C. 12. Python with pandas is in use in a wide variety of academic and commercial domains, including finance, neuroscience, economics, statistics, advertising, web analytics, and more. Let's talk about the mission of pandas. Pandas aims to be the fundamental high level building block for doing practical, real world analysis in Python. Additionally, it has a broader goal of becoming the most powerful and flexible open source data analysis or manipulation tool available in any language. Then, what is the vision of pandas? A world where data analytics and manipulation software is number one, accessible to everyone, number two, free for user to use and modify, number three, flexible, number four, powerful, number five, easy to use, and the last, number six, fast. So quickly look at the features of Panda. So what we have learned so far, Panda is the most popular library used by data scientists for doing data analytics, as it is capable of doing many tasks, such as it can calculate how the data is organized, that is across rows and down columns. It provides powerful functions to slice the data, merge the data, concatenate the data, and reshape the data. It provides functions like drop NA and fill NA to find and fill missing data. It supports visualization by integrating with other libraries like matplotlib and seaborn. It contains high level data structure and manipulation tools, which makes it very easy to work with pandas like their data frames and series. Applications of pandas are numerous. As I've told you earlier, it has huge application in the field of economics, stock prediction, advertising, analytics, neuroscience, statistics, big data, data science. Now, how the installation of pandas took place. Python, if installed through Anaconda installer, then Numpy, SciPy, Pandas, Matplotlib, etc. are by default installed with Python. Sorry. Otherwise, you need to install these separately through pip installer function. Pip installer function, what is it? So let's see what is a pip.
To start with, we need to talk about pip. Pip is Python's package manager. It has come built into Python for quite a while now, so if you have Python, you likely have pip already. Pip installs packages like TensorFlow and Numpy, pandas and Jupyter, and many more, along with their dependencies. Many Python resources are delivered in some form of pip packages. Sometimes you may see a file called requirements.txt in someone's folder of Python scripts. Typically, that file outlines all of the pip packages that project uses, so you can easily install everything needed by using pip install-r requirements.txt.
So this is all about pip. And on installation on ideally, steps to install pandas on ideally are as follows. Like, you have to go to Python folder. Here I have a video. Let me show that video to you to make it more clear. Make sure that you install your Python in C drive and then click on script folders On the address bar, type cmd, then a command window appears. There you write pip install pandas. Once you type it and press enter, you will find a successful message over there. In my computer, as it is already installed, so the message doesn't appear. To check whether it has been successfully installed in your computer, on the Python shell, type import pandas as pd and click enter. If you find no error message there, that means successfully Python has been installed in your pandas has been installed in your computer. In the similar way, Numpy can be installed. Instead of writing pip installed Python, you have to write pip install numpy, and in this way you will, after pressing enter, you will get a successful installation message, and again type import numpy as np and you will find it there in your system. And in the similar way, matplotlib can also be installed. Matplotlib, what is it? So let's start with its discussion. Python supports data visualization by matplotlib libraries and pyplot modules. What is data visualization? It is a graphical or visual representation of information and data using elements like charts, graphs, and maps. Matplotlib is a Python library that provides many interfaces and functionality for 2D graphics similar to MATLAB's in various forms. Pyplot is collection of method within Matplotlib which allows user to construct 2D plots easily and interactively to visualize data. The Matplotlib is pre-installed in Anaconda distribution as NumPy and Pandas. For its installation in IDE, you have to write pip install matplotlib on CMD window as we have done earlier for pandas and for NumPy. Here you can see some commonly used charts types which are provided in matplotlib library like bar graph, histogram, scattered plot, area plot, pie plot, etc. Hence we can say that data can be explored in many ways in Python by using these libraries such as NumPy, Pandas, and Matplotlib. Again, NumPy, to summarize you, NumPy stands for numerical Python. This library contains basic linear algebraic functions, Fourier transformations, advanced random number capabilities. And what are pandas? Pandas for structured data operations and manipulation. It is extensively used for data merging and preparation. Matplotlib, on the other hand, is a Python-based plotting library which offers Matplotlib with a complete 2D support along with limited 3D graphic supports. Alright, after the discussion of those libraries, you have discussed the libraries in detail and the top 3 libraries, that is NumPy, Pandas, and Matplotlib. Now we are going to discuss deep in data structures of pandas. To understand it further, let's start with the discussion of pandas data structure. Hope you have enjoyed this video. Now let's talk about the data structure in pandas. A data structure, you might be thinking that what a data structure is. A data structure is a way of storing and organizing data in computers such that it can be accessed and worked in appropriate ways. Pandas is having data structure, as you have seen in the video, three types of data structures, and pandas are enhanced version of Numpy. Pandas deal with three types of data structure, that is series, frames, and panels. Let's discuss about series. So what a series is? A series is a pandas data structure that represent a one-dimensional array-like object containing an array of data and an associated array of data labels and its indexes. It has two parts, as you can see in the diagram, that it is having series index, series name, and series value. Series values are what? They are the array of actual data, and data labels or series index, they are associated array of index with them. When numpy is already there, then there might a question arise in your mind that why pandas series. So let's quickly find the difference between the numpy array and pandas series. In NumPy, vectorization operations can be performed, but they can only be performed if the shapes of the two ND array matches. Otherwise, it returns array. That means if you wish to add or do any calculation on NumPy array, only if their shape is matched, then only the operation will take place. Otherwise, an error message will be returned. Whereas this is not the case with the pandas series, where vector operation can be performed and it will be aligned only with the matching indexes. For non-matching indexes, what will happen? A nan will be returned, means no error will be returned, a nan will be returned. Number two, in NumPy array, the index are always numeric. That is, they start always from 0. Whereas in series, the index can be of any type. They may include the number, but it is not necessary that they should start with 0 and they should always be a number. They can be of any data type. Number 3, the NumPy array has an implicitly defined integer index used to access the values, whereas the series may have explicitly defined indexes associated with the values. When NumPy was there, then there was an advantage of series, and when series were there, then why data frames? Series objects are single dimensional objects. They are not capable of representing real life data at a time which is multidimensional. For this purpose, pandas provide some more data structures such as data frame and panels, etc. The data frame objects of panda can store two-dimensional heterogeneous data. So let's talk about data frame in detail. A data frame is a two-dimensional labeled array-like pandas data structure that stores data in different types. First, it is created using pandas.dataframe function. It's to create a data frame, you have to write pandas.dataframe function in this way. A data frame contains heterogeneous data. A data frame is size mutable. A data frame is data mutable, and it is capable of performing arithmetic operations on columns and rows. Here you can see that this is a data frame, and a data frame itself is a combination of series. Means a series is single dimensional, one dimensional data structure, whereas pandas is a data frame is a combination of those single dimension series, thereby making a two-dimensional data structure which is having columns and rows. So we can easily differentiate between series and data frame. A series is a one-dimensional array-like object containing an array of elements. On the other hand, a data frame is a two-dimensional object of heterogeneous elements. Being a one-dimensional series is having only one axis, that is axis 0, and a data frame, it has two axes, axis 0 and axis 1, where individual columns of data frame can act as a separate series objects. So with this, we have come to the end of our session. Let's quickly recap what we have learned so far. We have learned what are libraries, the three types of libraries. Among the pandas, we dug a deep and known about the series and data frame two data structures of pandas. And to quickly recap the entire session, let's summarize it.